like if you are interested in capturing the telemetry of your application, right? Let's say you have a lot of infrastructure, which is generating a lot of logs, and you want to see if there are any anomalies, right? It could be anomalies due to denial of services or intrusion attacks. You could identify those patterns. So if you want to embed some AI ML within that, you could use one of our standard APIs out of that. Now, for people who are like data analysts, they could be business analysts who would be writing a lot of SQL queries interacting with the databases, right? You could use BigQuery ML. So BigQuery is our serverless data platform, data lake platform, or data warehouse platform. We support a lot of models in that. Like, for example, for regression, for classification, we have a linear regression, XGBoost. We also have a time series that we have just released. We support ARIMA forecasting there. Now, for some of the more advanced enterprises out there, like the Uber or Lyft, who's building and deploying multiple models every day, right? So they deploy multiple models into production. So they need to have a good, robust CI/CD pipeline for that. So in those cases, we provide some of the advanced frameworks. So at a high level, think about these factors before you start the journey of building your own custom model. Now let's take a look at, before you make a decision of building an model, what are the things that you have to, like, it's more like a flow chart, right? If these checks are there, you could say, okay, you could use some of these solutions. Let's go through this example, right? So if you have a lot of training data, it has a lot of labeled data. So do you have it? Yes or no? If you don't have it, maybe, let's say you have a lot of data, do you have enough data more than off-the-shelf solution? For example, our Vision API, you could take pictures or send videos to it. It can automatically classify what is there in the image. And give you an example. There are power vertical companies or energy vertical companies. They do maintenance. They do predictive maintenance of their infrastructure. Like, let's say the windmill farms, or your electric utility power lines. If there are any damages to it, you could easily have like a drone scan those using from images, and you can identify, is there any requirement for any kind of maintenance on top of it, right? But in some cases, you might want to train it with images that are specific to the power vertical or energy vertical. In those cases, you could go for AutoML vision. An example for a retailer would be, you want, just taking a picture, you want to identify what would be the fabric, what would be based on the cuts and things like who would be the manufacturer of the product. So those kind of information you could train using AutoML. Another use case is speech to text, like when you're interacting with a call center agent, right? You're calling them. There are simple things that you might say, I want to check my account balance, or I think there's a fraud transaction. All of those could be automated. So that would save an enterprise a lot of money from like paying an actual person. So you could get a lot of significant savings. Another thing that we have found out in the recent last 3 to 4 months and during this COVID times is, like, when people cannot make it to the call centers or are not able to be as productive, you could automate a lot of these things. So make a decision, take a look at what are the options available before you start a journey of building your own custom model. So this is just a guidance. So the focus today is, once you've made that decision, we'll be trying to address how to operationalize your AI ML models. It should not be about, like for a data scientist or an ML engineer, they should not be spending a lot of time rebuilding their pipelines for each deployment. It's similar to your CI/CD for your regular software engineering, right? So about 4 to 5 years ago, that's when I started my CI/CD journey. Prior to that, like, it was more like a waterfall model where we used to have like a release manager. They would be responsible for downloading the code from like a code repository like Git. They would do the deployment to production, and usually any production deployment wouldn't happen more than once a month or even less than that. There was a lot of manual testing involved, right? So in my previous employer, they made a decision that they want to stop all manual testing, right? So They actually made sure it was all automated testing. They made a right decision in that direction. Initially, a lot of people were apprehensive of it. Look, most of the things we were so used to having manual testing being done for enterprise applications, could we actually automate all of those? Those are some of the challenges. But over the course of time, we proved that yes, all of that could be automated. So in MLOps, we are trying to bring a similar approach of bringing in the CI/CD, continuous integration, continuous development into this ML deployment to production. Think about like for the enterprises like Uber, who have to deploy and fine tune their ML models or retrain their ML models and then deploy to production almost once a day or more than that, or multiple models per day. They need to have a solid pipeline. They cannot rely on a human person to do these things manually, right? So that's the whole concept. Now, before I get into some of the details, I just also want to give a brief introduction of what is Kubernetes. I'm not going to go into the depths, but at a high level, very high level, what is a physical server? Like you have an OS, you have a physical machine, you have your applications. Let's say it would have a dependency on, let's say, Linux 5 or Linux 6, and maybe a Python version of 2.5, right? Whatever is that version, all of that gets installed. There is not a lot of failover built. If something happens to that physical server, everything crashes. Now, again, in my previous experiences, when we were building applications that was installed on a physical box like AIX, there's a lot of wastage of resources. You're not optimizing your resource usage to the 100% capacity, right? So then came virtual machines. VMware is one of the leading provider who came up with the whole stack, where you have a physical server. On top of it, you could abstract like more smaller machines. It's called as VMs. The beauty of it is on a single hardware, you could have multiple VMs. So you get some isolation. Okay, it's contained, but now each application has its own requirements. It has its own OS, and so there's some additional overhead, but that worked well for so many years. Now, what is container? Containers takes it to the next step of just abstracting the application's requirement. You don't need to have a separate underlying OS for each container. So that is the approach. Now, Google have started using containers for the last 12 years. One of the reasons was for us to support search, to index all the data and also serve all the requests. It wasn't possible to scale vertically. Right, so we had to make sure we are optimizing it enough so that we could scale it as needed when there's a lot of demand and scale down. So we came up with this whole concept like in 2004 of how to isolate your processes, came up with control groups, and then Docker came along, and then Kubernetes kind of orchestrates this whole workflow supporting your requirements for your containers. We'll get into some of the smaller details around that. So at a high level, when you think about a monolithic application, or let's say from a retailer's perspective, like you have a big merchandising application, right? It has a lot of functionality built into it. Just say, for example, in a merchandising application, creating your purchase orders, creating your items, your SKUs, and what else, like capturing your inventory. Let's take those as examples. Those could be each functions within a big monolithic application. Now, with containers, the approach that we're taking is you're breaking each of the individual functions into an isolated kind of execution and an isolated piece of code where it can run independently. Now, what are the other things to think about? Now, it's not just always about just running a business logic. There's a lot of other things that is involved with it, like security, your network, you're enforcing your different policies. Observability means like monitoring, logging, all the other things that comes along with running an application or doing your prod support, right? And then there's a lot of other factors like latency of my application. When your service is interacting with the database, what should be the latency tolerance? Circuit breaking is more like if I get a lot of requests, what should I be focusing? Is this a higher priority customer versus a lower priority? I could do a lot of quota and rate limiting. So there's a lot of additional functionalities that goes along with it. Kubernetes tries to abstract all of this. And what we try to do is, from a developer's perspective, you're just building your application code here. You're just focused only on that. And the underlying framework, Kubernetes, and also with Istio, we support all these other functionalities from a DevOps perspective. At a high level, that is the concept. So if you have any questions, please feel free to post on the Slack towards the end. We could talk, we could go through it, but that's all I wanted to cover from a Kubernetes perspective. Any questions? I could post it on Slack. I can give like maybe a few minutes to answer that. So go ahead.
We had a question related to BigQuery.
Okay.
In BigQuery, it was from Sukasis. In BigQuery, can we do ML on the near real-time streams, like Kafka streams?
Correct. So, so that's a very good question, right? So don't think about BigQuery just as a data warehouse. So we have a direct streaming option where you could just stream your data directly into BigQuery. Now, typically, like you might use Kafka, or our product is PubSub, where you use that as a buffer. So in case for any reason like you're not able to write to the endpoint, you want to do a buffer, you could use that. But in most cases, you could just directly write to BigQuery, and from the streams that are coming in, you want to derive more real-time information. One example was telemetry. As logs have been generated across a lot of servers, you want to identify, is there any anomaly? Is there any DDoS attacks that are happening? Yes. So you could apply that on your real-time streaming that's coming, and you don't have to rely on Kafka or PubSub. You can write it directly into BigQuery.
And a follow-up question was, do we need to store the data in BigQuery before we do the ML?
So when you're writing it into BQ streaming, it actually writes it into a table. So in a matter of hardly less than a few seconds, you can immediately apply any inference that you want on top of it. Maybe let me see if I have an example towards the end once you get into the labs. Once you finish all the labs, I have an example and I can walk you through it, how you can apply that. Okay, so moving on. So over the last couple of years, these were the different focus. About 3 years ago, it was all about what is ML, what is AI, what is the right problem that I can solve using AI and ML. So not all problems can be solved using AI and ML. Like, interestingly, like after joining Google, I see a lot of questions from customers. Can I solve my assortment planning or any other things with just AI ML? But to me, the answer is, let's take a deeper dive. There would be like problems within that space where you could apply AI ML, but not everything is just AI ML. You'll also have to think about who are your end users and accordingly build it, right? Now, that said, this is not just 3 years ago. There are different enterprises are in different stages of their AI ML journey, right? I do work with customers who are at maybe, like, if you look at it from 1 to 10, like 10 being the highest, there might be around 9 and 10, where they are deploying models into production multiple times a week. Versus I do support other customers who are very early in their journey, right? They are just trying initially to identify, okay, can I solve this use case? What is the right use case? And building their data pipelines. Over the last 1 to 2 years, you could see like the other questions are, how do I build my whole data pipeline? Like, for example, the question that was just brought up was, can we do inference on real-time streaming? So how do you build the whole real-time streaming? In this case, you can take a look at an example. You have data that is being generated from as customers are clicking through the apps, or from your websites, or from IoT devices. So I want to show you this. So here is kind of an IoT device. So this is called Coral, which is like a hardware that is built by Google. You could deploy your AI ML models on this device. So this has a TPU, and I'm working with a few customers where, like, during this time, they want to identify, are people maintaining safe distances? Are they covering their faces? And an example is, like, in a retail store, where are people spending most of their time? So there are different use cases. Now, you could bring in all this data into your cloud environment at real time. Now, in some cases, when you deploy models at the edge, you don't want to send the images or the videos to the cloud. The reason being, privacy might be a concern, right? And to answer the earlier question, look, this is the same kind of architecture. You have a PubSub or a Kafka for real-time streaming. As the data comes in, you could, so data flow is our data processing engine. It is based on Apache Beam, or you could use Spark streaming and run real-time inferences. You could also land it in BigQuery and also run real-time inferences on top of it. And within BigQuery also we have BQML models. And now what's happening in the enterprise space most recently is, how do I deploy my ML models into production faster and with scale? So as an engineer, you don't have to be worried about your different environments, from your dev environment to your test environment to your production environment. Everything should be seamless. Like in the past, I would say, like, I don't know about everyone, but I used to build my stuff on my laptop, move it into a test environment, and then move it into production. There could be version issues, library changes, and then sometimes I had to raise tickets with my Unix admins to apply the right libraries to the right test environment and to the right production environment, right? So anyway, these are some of the challenges. We are trying to address that by using MLOps. So that will be our focus today. So again, just stating that, okay, deploying to real world ML app is really hard. So how do we make that smoother? So as an enterprise, you're not focusing on building and supporting that. You just have to focus on building applications that shows a differentiator for the business, right? If you look at it, the actual time a data scientist or an data engineering team or ML engineer who's actually responsible for building a model, if they spend, let's say, this kind of shows that. But what are other challenges that surrounds that? Like spending your time coming up with the right infrastructure, configuring the right infrastructure, collecting your data, trying feature extractions, right? Verifying your data, monitoring, building the whole monitoring logging system around that. These are all a lot of challenges. Like, again, I'll go back to my example from my working with other customers and in my previous experience, where we had to build like a planning system. Right? I have to open tickets, work with another team. I need these data. We didn't have like a central data repository that we could just, as a data scientist or ML engineer, we could just directly pull the data, right? And over time, you could see people are spending time to come up with this centralized data catalog where you could expose all this data to all your consumers within the company. So you're building more like a data platform. Some of the things that you're looking for in your AI platform is, how can we allow those data scientists and ML engineers to improve their productivity so that they don't have to be focused on all this other engineering work? So an example, like if you look at what is the different stages, you have a data ingestion stage, analyzing your data, transforming your data, data validation. Like I'll give some examples, like for example, in forecasting application that I was responsible for, like you have to look at, there would be reasons why I didn't make a sale at a store. The reason being I ran out of inventory. But when you're using that data to forecast, you don't want that pattern to be repeated, because I knew there was a reason why I didn't make a sale, because there was no inventory. So in those cases, we apply data pre-processing, like smoothing your inventory dips, and that could, we could say, okay, this was the reason for for an out of stock indicator that will help pre-process your data. Right? So that is the first stage. And then as a data scientist, once you get all your data validated, pre-processed, next you're using that to build your model. Again, just giving it a lot of data to train. And then once you get the results, you want to make sure there's no bias. But again, think about, I'm going to use a lot of examples from retail, because that I've been working in that for a long time. So think about, like within a retailer, they have different categories of products, right? You could have men's, women's, shirts, shoes, you have like home goods, electronics. All of them have different patterns and different features. So when you're building a model, think about, and again, it's not one model fits all use cases. Now, if you look at it from a real estate perspective, right? If you build a model to identify objects within a room, right? There are different kinds of rooms in a house. You have your bathrooms, you have your bedrooms, you have a kitchen. You need different data sets to train each of this. And then again, trying to build one big giant model with all these objects might not always be optimal. And it could be also an ensembling of models. So as a data scientist, you're doing and trying out all these different options and iterations. And then once you have something, you've deployed it to production. Now think about this, like once you have deployed a model into production, is that the end? No, it's not the end. The reason is, best example is this COVID times, right? If a real estate model that was supposed to predict the value of the home, if it just continued doing the same thing that it was doing without any kind of retraining, it would have predicted the home prices are going to go up. Same thing for a retailer. If you're just trying to forecast sales, you might say, oh, okay, based on my last 6 months or 12 months, I think the sales is going to go high. But it needs a lot of retraining because we are seeing now there's a downward trend that is happening. So there is always another concept of continuous validation and continuous monitoring in production to see is there a model drift based on the current factors that are. So it always requires some retraining. Right? And how do you make sure these things happen? Now, these are some of the extreme times. So what in some cases, I know some of the enterprises, they just stopped forecasting. They did the forecasting, but they didn't send the numbers out, right? So they didn't want these forecasting numbers to generate purchase orders that would bring in more inventory into the store. So they just blocked that, but they still wanted to see how the systems were behaving. So I'm going to say, okay, so these are the different systems. Again, when you say different systems, these could be different operating systems, different frameworks, and so which doesn't give a whole smooth connected experience across. Now, again, as a developer, when you're building things, you have a certain framework that you're trying out on your machines, right? Maybe on a training environment, it might be on a unique server. When you're building a model, you might be using your MacBook or a Windows laptop, or in training, you might be pushing it into a unique server. And then when you're deploying it, you might be deploying it to cloud. You don't want to have a disconnected experience across each environment. So that's what we're trying to solve using our MLOps pipeline. And underneath it, so these are some of the challenges that you would run into. As an engineer, are you going to focus more on learning Kubernetes, containers, packaging, all the CI/CD works that goes along with it? I can tell you from my working with a few enterprise customers, like who are really good data scientists and engineers, they don't want to be bogged down by the administering the underlying infrastructure. Like, for example, even when I was not like in my regular engineering days before joining Google, like I was focused on application dev. I wasn't interested in managing my Unix servers or my database admin. So they had separate roles for those. So those are the things that we are trying to optimize. And by moving to a managed platform, as a business, you just focus on building your features. So let's take a look at some personas, user personas. Right? So in this case, I'm a very productive data scientist. I train multiple models. But again, when it comes to deploying models and keeping track of the models that I've built, I'm using a spreadsheet. I mean, I know this has happened like in the past when you have to keep track of your code. If you don't have a repository to check in your code, you keep like maybe you save it in a folder in your own machine. Interesting, I've also been talking to one of my colleagues. They're working they're working in building a kind of a voice platform, which doesn't have a code repository. So they keep saving everything on their local laptop. So that's not a really good experience. And the thing is, maybe the model that you created last week would have given you better results. But how do you keep manually relying on something so someone to do that is not a right approach. So these are some of the challenges. So how can you solve that? By having a simple SDK that can capture this information for you and track it. So as a data scientist or an ML engineer, you don't have to be focused on that, right? So that is what this platform supports. So Kubeflow is our platform. So for example, the things that you can capture are what were the hyperparameters that were used for this specific model. Now, let's say in a forecasting model, you might have different parameters like we have used Bayesian criterion, or there could be other thresholds that you could just adjust in certain use cases. Like, for example, the reason why you would adjust Bayesian coefficient is I want the forecast to be aligned more to the sales or more to the history or more to the plan, right? So you have those different hyperparameters that you want to adjust. Again, based on your model, you might have multiple hyperparameters. and you want to keep track of what were the values that you had used. What was the code that was used when I ran that model? I might have made slight tweaking in it. You want to track it. Where is it stored, right? You could use our cloud object storage, which is Google storage, and you can put you can dump it over there. That's where we use that to track it. And then you could actually use TensorBoard to look at the analytics of the different metrics. How was it behaving? So this is the whole platform, and it'll give you when was it run, the start time, end time, the duration, what are the different parameters, and again, all the parameters that gets captured depends on what you decide to capture, right? You can come up with your own custom metrics. Like, for example, if it's specific to, let's say, real estate, you might want to identify maybe these were the clusters that I used in my training, or anything else, like this was the accuracy score or whatever. You can capture all that information here. These are the, like, you have your precision recall graphs. So this is that one framework. And again, Kubeflow is an open source product. Google had started and contributed to open source. I forgot when, it was about a few years ago. And then other players like IBM, Microsoft, everyone is contributing to it. It also provides, if you again decide to capture based on your model, if you want to capture the confusion metrics and all, you can do all that. So you have one place to go and review all these information. Right? You could also look at your code. Now, between the two runs, what was the change? You could actually do a comparison, line by line, and see, oh, these were the changes. Okay. Now, assume that it has captured that. Now, I'm a very proactive data scientist, and I'm able to deploy multiple models. Now, again, some things that I need to make sure is, once I've deployed the model in production, as new data comes in, how do I identify that? There should be some continuous monitoring that happens in production. Like, the best example is how the home values has gone down in the last 3 to 4 months, right? Or for retail, how my sales volume has gone down, right? So all of that, you have to continuously keep monitoring it. The typical, like, you might come up with a schedule like maybe once a week, once a month. Again, it depends on your domain and your requirement. So underlying, we make sure we have this metadata tracking store. Within Kubeflow, we use Cloud SQL. It's a MySQL version to track the metadata. And then all the metadata is actually, the actual data is actually stored on cloud storage. You could also use this for any kind of training and serving for batch prediction. Now, there are use cases where you might have to do real-time prediction in case of, let's say, who should be the driver that needs to be assigned when you hail a, like using some online cab ride sharing thing, right? But if it is something more like a sales prediction for a retailer, you might not need that to be real, right? It can be once a day, or in some cases once a week for high-end fashion. Like, I don't need like a daily forecasting. It depends again on the domain. Now, let's say in cases where a specific step has failed, maybe for some data issues or something, in this pipeline, you can just rerun once you fix the data just from that failure point and then continue. You don't have to start from the beginning. We have checkpoints built. Now, this was another question, like one of my customers were asking. So they were building a linear regression model. They have like a big VM with close to, I think it was 96 scores, and they were just trying to do a linear regression. The way they had designed it, they were reading a lot of things into a data frame, which is not a good approach. Just trying to load everything into memory, and the system was crashing. Now, they were not doing checkpointing. So what checkpoint means is, as your model is running, you're also saying this is the progress. And when, for any reason, if the job fails, when you rerun it, you can just rerun from that last successful checkpoint entry, right? Also, you need to keep track of all the lineage, the data lineage, or what is the code, and you can use all of that as input. So when if for any reason you have to go back and restore a previous model, you know which one that you're picking. So again, it's all about enabling your data scientists and ML engineers reliable experimentation. How can you quickly reuse codes? Another thing to remember is when you're building something, you have to modularize it. Like create as many parameters you can. And let's say you have an input file parameter or an input table parameter and an input or a processing function. Provide those as parameters to your jobs, and then you can reuse your modules. So as we go through the labs, you can see it will walk you through the examples. It'll be more clear when you do some hands-on experiment. So like I said earlier, continuous training and monitoring in production is really critical, right? So you have to build a CI/CD pipeline to build your and do some automated testing, like simple testing. Could be simple tests like, okay, when I provide these inputs, is my existing functionality working? I might have tweaked something else, maybe added some additional pre-processing logic, but I should make sure all the previous cases are all working, and then continuously deploy that. So it requires more effort than a typical DevOps, because now you're supporting other roles like data scientists and data engineers. It's not just from an engineering perspective. Let's skip through this. Now let's take a look at what does a traditional ML workflow look like. So you have a data acquisition, exploring your data preparation, feature engineering. You have some model selection. You identify whether it's a like linear regression, XGBoost, or different kind of options. And then you train your models. And in some cases, you have to come up with the right hyperparameters. And then deploy a prediction endpoint. And then once you've deployed, remember that validating your model continuously in production, and then monitoring your models, right? Now, when you look at the different maturity levels of enterprises, you could find it could be anywhere between here. And even though this is just a guidance, okay, it's not like set in stone, like, okay, there's only 3 levels. And you could, when we say level 1, it could be it's just a guidance. And some people might be somewhere in between 0 and 1, or it could be different combination of things. Let's go through those different maturity levels. At a high level, when you say manual deployment, what it means is, as a data scientist, you do most of your steps manually, and let's say you review your features, you prepare your data, do your model building, and then you deploy it. But all of this happens still in a manual fashion. There is no CI/CD approach, right? So that is the manual deployment. What are some of the challenges there? So typically the way they work is you might have a Jupyter notebook where you're building your models. You do some manual hand it off to someone, and then you deploy it into production. So the problem with that is the release cycles to production would be limited. It might be once a week, once a month, and things. And you don't have a continuous integration or continuous testing over there. So again, some of the challenges that you would typically run into is human error. And you might be also biasing your data. The data set that you would have picked, let's say in case of retail, you might have picked just women's shoes or women's clothing. You might not have looked at home goods and other things. So there might be a personal bias that gets added to your model that gets built. You don't have an automated retraining cycle. And once you deploy to production, you're not continuously monitoring for model drift. Now, when we look at level 1, again, I'm not saying that this is the exact level 1. Every customers would have different components of this, right? So as part of your experimentation pipeline, you would have a data validation preparation, training of models. You have deploying it into a source repo. You have a code repository there. And then you're also automated, you're retraining your models. You have a metadata store. Now, what is feature store? Like, in some of the challenges, like I mentioned earlier, was for data scientists and ML engineers to pull data from different parts of the org. To make it abstract and more easier, we're trying to build this central feature store, and where you can just extract data from there, right? You don't have to think about building all the data pipelines that gets the data into feature store. It is already aggregated. Let's say, for example, again, from a retail perspective, when you're looking at the transactions that's happening at a store, that's actually happening at a register level. You have POS registers, let's say at least 5 or 10 per store. You want to aggregate that and maybe just say at a store for a given SKU, I sold 10 units, right? So you're doing all those aggregation and bringing it into the feature store. You're abstracting all the point of sale level transaction. and then deploying to production. Okay. We'll go through some of the features of this level. So you have built an experiment automation. You have it's a more complex pipeline than the previous one. You have modularized your components for reuse. You have continuous integration, but you don't have continuous deployment for your pipelines. Right? Again, these are some just suggestions. Some of the challenges, again, you need someone to be able to build a pipeline platform, developing and maintaining the test codes for automated testing. You need to have ML engineers. These are things you have to keep in mind. This is a different framework. And when you look at level 2, so you have more automated testing that's happening, right? So you have your source code that has been checked into your source repository. So for example, as soon as you check in code into your dev branch, you want to have automated testing that kicks off, that validates like maybe 10 scenarios. Once that passes, you would push it into your production branch or a test branch, and then it moves into production, right? So that is the whole concept. Once you have done your automated pipeline, you need to deploy it at your endpoint, which would actually serve, could be a batch prediction or an real-time prediction service. And then continuously monitoring for performance, that is key, right? You have to always make sure you have something that keeps evaluating the accuracy. Now, again, going back to my example from retail, we used to have forecast scorecards. So what forecast scorecard was actually showing the merchant buyers was how good was your forecasting compared to the actual sales that happened at the store. And their bonuses were actually kind of very depending on the forecast accuracy. If their accuracy was like way off, it doesn't justify giving them a good bonus, right? So think about from that perspective. When you are building something for a business use, you should be able to quantify the benefits of it, right? Oh yes, by making this change, I saw this percentage of improvement in maybe my home prices. It was more accurate, or whatever is that feature that you're trying to do. Okay. So at a high level, if you're deploying this using different Google components, you could think about this. So you have your source repository, so that's our like similar to Git. You can check in your code there. And similar to Jenkins or building a code pipelines, you could use Cloud Build that will automatically run unit tests. You're creating, as soon as you make a change, you're creating a container, it'll automatically, and check-in, it'll automatically trigger all those changes. Container registry is similar to like a Docker Hub. This is our container registry to store all your container images. Cloud storage is our object storage. And this is our automated pipeline where you have different stages. We're deploying pipelines into Kubeflow. In our lab, that's what we'll be doing today. And for Jupyter notebooks, you could create a Jupyter notebook, and we'll be also doing that. We'll be creating a Jupyter notebook in AI platform. And then you could schedule your jobs, like at what time you should have these pipelines run. So you could use something simple like Cloud Scheduler, but most people use Airflow, right? So for people who are using Airflow, we have Cloud Composer. Okay. Any questions on this architecture? I think that we are almost towards the last. Okay, we have a few more slides. So some of the features of this, again, you have built a continuous integration for your models and pipelines. You have a continuous deployment. Your automated triggering, that as soon as you check in code into your Git repo, it will start your container builds. And then you're continuously monitoring for your ML metrics. So recently, again, one of my customers recently, they wanted to build a model logging. So they have deployed their models on their website. So they want to make sure how their customers are interacting with the products that they have suggested. Now, they had a big batch window where it was in the last 2 to 3 hours, it was creating a lot of logs. So their question was, how would I capture all these logs? So they were looking at different options. Again, it could be a mix of Kafka, PubSub things, but then a lot of things to think about. Like it's not just about a technology perspective, like for some things like logging, what is the cost that I'm willing to pay for it, right? So those are factors that goes into it when you're coming up with the whole monitoring pipeline. And then canary deployment is something where, let's say you built a model and you want to test how good is it. So you could deploy this to a subset of users, maybe not a high-risk category of customers, so that maybe if the model doesn't behave well, I'm not losing a lot of revenue, right? So we could think about that, like deploying this model, test it out first. If you see an improvement, yeah, then go ahead and roll it out for everyone else. Again, some of the challenges that you would run into is building that DevOps culture, MLOps culture in an engineering team. Yes, there is some initial learning curve, but once you have got that learning curve, the whole experience is really smooth, right? So this was my same approach when I was initially thinking about moving from the old way of engineering to moving to a DevOps and CI/CD engineering approach. I'll quickly talk about hybrid AI. So like all these things, solutions that we have provided was okay. You can deploy that on Kubernetes, as we supported on. It is like you can actually deploy it on any cloud. But some of the way we make it really easy for users is by having our managed pipelines and managed and serverless environments. Right? Now, if you want to apply the same to your on-prem, you want to bring it to your on-prem infrastructure for any reason due to privacy or concerns or whatnot, where you cannot go to a cloud, you could apply it on Anthos, which is our way of managing your Kubernetes environments either on-prem or on GCP or on any cloud. So recently, the US government has selected Anthos as the platform for managing their hybrid cloud requirements for containers. So we support this on-prem, on GCP, or any cloud. Right? So you could get all those features and deploy those. So that's all I had. So we can spend like 5 minutes if you have any quick questions, or we could start the lab. What do you want to do, Vishal?
Yeah, we have some questions in the thread. I will go over them.
Okay.
Meanwhile, we go through the questions. If anyone is not yet signed up with the Quick Labs, please make sure you sign up with the instructions posted in the Slack channel. If anyone has joined new and don't have this link, Kaushik, please post the link once again for Slack. And we have the thread there. Yeah, we'll go over some questions for 5 minutes and then start with the lab. So this is the time for you to set up your Quick Labs if you haven't and post your questions on Slack. Okay. We have a question from Marcio. He was asking, what's observability in this context? Can you give us a concrete example of what it involves in practice, like skills and tools?
So think about from observability is how is your model behaving, right? How is the infrastructure behaving? Give you simple examples, not just from an AI ML perspective, right? You have a lot of infrastructure that is running. And these are some of the common things that I hear across enterprises. Yeah, we have started on the cloud journey, but my expenses are rising. It's just that because you're not looking at what's happening under the hood, right? It's exposing you to that. Let's say in this case of models or AI models that you have built, let's say for forecasting your home prices, what were the factors that went into making that prediction for that specific property? So you want to keep track of it. So later, when you find there is an accuracy difference, you're able to go and quantify what is the reasoning for it. And then if you feel that you might need to tweak your model, these are the factors that will help you make that decision. It's just giving you more details about what was the reason for predicting, giving that prediction number. And it could also be from an infrastructure perspective. Let's say you're deploying this on a Kubernetes environment on-prem. It's also looking at how is my resources being utilized, and all of those factors. It falls into the observability term.
Bibin, we have another question from Atul. So he's asking if on how to determine what ML algorithm to follow when training ML model, especially from beginner's perspective.
From a beginner's perspective, I'll give you some simple example. I'm not going to go into all the details. Let's say you want to predict some numbers, like in case of retail, I want to forecast how many units of this shirt I'm going to sell at the Seattle store. So there could be a linear regression. You could also come up with something more like some combination of neural networks. You have deep neural networks or deep and different combinations. Now let's look at another example of, should I target an ad to this specific customer? Let's say we typically, when you're shopping things online, you might find something, oh, this is interesting. I put this into my shopping basket, right? My shopping cart. Now, from an enterprise perspective, we might see, okay, is it worth retargeting an ad to this specific customer? So I might be okay spending $1 for that ad. And if I do, is there a propensity for him to buy? So that's called as propensity to buy or propensity to sell, whatever is that. So you could see that could be a classification problem, right? So you could, and maybe later, once I'll show you some of the options, even within BigQuery, you could use, we support linear regression, classification, XGBoost. Let's say in other cases, time series forecasting, where I want to forecast for the next 60 days or maybe even 90 days of how my sales is going to look like, so that I can create the right purchase order. So that, let's say, as a retailer, you want to order Nike shoes, maybe thousand shoes, right? But I have to know this is my demand over the next 90 days, and accordingly place the right purchase order request to a supplier. So those are some of the examples. If you can ping me, I'll also share some additional materials later.
All right, so we have one more question from Key. Is there any way to stream data from SQL Server on-prem to BigQuery?
Okay, so yes. So typically for that, we would recommend some kind of change data capture, right? So out of the box, like we do have a product that we have launched, but that is more from MySQL to our cloud SQL environments. We have also started supporting cloud MySQL on GCP. So again, at a short answer, right now we don't support MySQL, Microsoft SQL server streaming, but there are change data captures. You could think about third-party tools like Stream. So Stream were the founders of Golden Gate. Golden Gate is also an example, but it also comes up with a licensing cost. Or you could come up with your own way of generating the streams. Okay, now that said, we also have a product called Cloud Data Fusion. So the intent for Cloud Data Fusion is you could connect that to an on-prem solution or any other third-party cloud solution. And then as changes are happening, it could get captured and is defining a pipeline and writing it into a data store. The data store can be BigQuery. Or another example is you could come up with triggers, right? I think probably SQL Server should be supporting triggers, right? So as data gets added into a table, you can trigger that to write it into like maybe as external staging table, and that can, or it could generate an event, and that it could be written into PubSub, Kafka, or anything.
Right, thank you. And we have one more question from Arisa. What is a reasonable minimum data that can be used to generate an ML model? Is there a unit in which this data is measured?
So I will give an example again. This is from AutoML Vision. Like we had a requirement to identify, again, in a house, what are the different objects? Like let's take an example of a kitchen. What kind of cabinets, what kind of appliances are there? So what we recommended was at least 300 images of a specific object. Let's say if it's a dishwasher or things. Now, similarly, I was supporting an energy vertical company where we had to do predictive maintenance. So I had to give it enough examples of, let's say, a fuse blown out, or like a power pole which had splints on it, right? So that said, you don't have to provide always all the examples, because you don't have to come up with it, because we might be able to use public data sets. So that is one. In one case, we actually used one of my customers, they had used a third-party API that was able to give the initial labeling. We used that labeling to actually train AutoML, and then AutoML was able to identify that. But again, it depends on, I would say, at least 300 examples for an image perspective to train it. Again, from a retailer's perspective, again, by the category of products, you might need so many examples across categories, and per category, per item, you might have again. And again, it differs from a regression perspective. If it is like linear regression, generating a time series forecast, you need to have multiple patterns so that it could generate a trend at an aggregate level. So I would say from an image 300, that should be good.
Thank you, Bibin, for answering those questions. So please feel free to post your questions in the question and answers thread, and we will address the remaining questions at the end in the QA answer section. And now we'll move on to the labs.
Okay, so this is how I'll do it. So I'll go to the lab and we can go through it together, and then as questions comes, feel free to post it, and then we'll go through it together.
Yeah.
So
as everyone got the monthly subscription, I have posted the link to the lab that we are doing today. Please open that link. I'm posting that as well in the chat. That's the lab that we are going to do today. Go ahead. Sorry.
okay, so I hope you can see my screen where I'm going through the Kubeflow pipelines with AI platform. So, so what are the objectives of this lab? We'll be creating a Kubernetes cluster, but again, don't worry about it. In this case, just creating a Kubernetes cluster is just a button click. Everything else made seamless for you. And then it'll also install Kubeflow pipelines. We'll also launch an AI platform notebook, and we'll run an example of how to deploy an ML pipeline into our platform. Okay, and then we just look at the steps, and we'll also run a separate set of code. I'll walk you through that. Okay, so once everyone is here, I'm going to go ahead and start the lab. So I'm going to move this screen to another window so that I can open an incognito window. Hope you can see my incognito window. So go to console.cloud.google.com. Okay. So you could see here, this is your username and password. Copy your username. Okay. Hit accept. Just hit confirm there. So what's happening behind the scenes when you start a lab is an environment gets provisioned for you in our data center. And one thing while you're going through the lab, always make sure you're just following the right regions. Now, like we are going to spin up about 50 GKE environments, GKE nodes. So all of them, they said they have capacity that's dedicated for Cloud Lab. So just quick labs. So just follow the same instructions. So once you have done that, the next is we'll be setting up Kubeflow pipeline. So before that, I'll just walk you through the console, right? So this is just we call this hamburger menu. So just remember that. Select a project. So when you select the project, go select the project that has the Quick Labs in the prefix. So select it. Now, one thing, again, this is as part of a lab, you're going through this. But once you're in production or when you're building things, you're not going to interact a lot with the console. So maybe for AI and ML more, you might interact, but once you're doing more of a cloud native engineering things, you should never be going through the console to do all the deployments and things. It should be in some kind of native framework. You build your code like IntelliJ or things, check in your code, and then that's how things should go into production. So for today, we'll go to AI platform. So this is, so over here, you could see some basic information about your projects. You could just choose to ignore that for now. We'll focus on AI platform. So click on AI platform. So once you're there, we have pipelines. So click on pipelines. So we're going to create a new pipeline, right? So click on new instance. So what happens behind the scenes is it takes you to marketplace and it'll start provisioning an instance. So once you're there, hit configure. Okay. Now, in the first case, when you say create a cluster, behind the scenes, it spins up a GKE environment. So if you go to the instructions, they have said allow access to all to the following cloud APIs. So what it means is the underlying GK will have access to all the like BigQuery, cloud storage, and everything. So it needs some authentication for that. So we're just enabling that. Since we don't have a cluster, now let's say you already had a cluster, you could just pick that cluster as in this environment and it's freshly created. It doesn't have any cluster. So it's going to create a Kubernetes cluster. It might take about 2 to 3 minutes to get built. So while that happens, if you have any questions, is everyone here at this step? Or does anyone need any assistance? Please post it to Slack. So while that is happening, I'll walk you through the rest of the process. So once the cluster gets created, we'll be deploying Kubeflow on top of it. Now, in our case, we will not use managed storage for Cloud SQL. What it means is, by default, we have a MySQL running on GKE, which is our Kubernetes environment. But typically, I would recommend don't go with that if it's a production use case. Click on Managed Storage, which means you're using our managed Cloud SQL environment where it spins up a Cloud SQL, which is MySQL, and then that's more reliable than this. For all production use cases, use that. Okay. After that, we'll be creating a Python notebook, Jupyter platform, Jupyter notebook. Okay, we'll be going through that instructions. Maybe in the interest of time, we could also open another console. So go back to the original console. You could go here on notebooks. You could also follow the same step. Right? We could create a new instance, pick TensorFlow 2.1 without GPUs. Leave all the default settings there and go ahead. Hit create. Now, while this is happening, still the cluster is getting created. I'm going to open another console just to show you what is going on behind the scenes. So go back to console. Let's go to compute engine. Right? So behind the scenes for our Kubernetes infrastructure, it needs VMs. So these are the VMs that got spun up as part of the Kubeflow environment. Right? So we have 3 VMs for that, and this is the last VM that got created as part of our Jupyter notebook, right, from AI platform. So this is getting spun up behind the scenes. Any questions? Is everyone here, or does anyone have any issues?
I hope everyone got access to Quick Labs and following through. Or else if you don't have any questions, we might think you are lost. So please let us know. If you're good, let us know in the chat that it's going good. Or if you have any issues with the labs, post in the MLOps attendees channel, and we can take care of it.
Okay. So in our case, our cluster has been created, right? So now let's follow the next steps. So next is deploying your thing. So just hit on I accept this. Now, like I said earlier, if for any reason, like it's a production use case, go with managed storage, right? And let's click on this. Use Cloud SQL and GCS for storing the data. This one tells you why, right? I'm going to hit deploy. It'll take about maybe a minute or 2 to deploy. So the beauty about this is, right, so think about, like, if you have to stand up your own Kubernetes environment in, let's say, in your on-prem infrastructure, there's a lot of installation things that needs to happen, right? Matter of 2 to 3 minutes, you have created a GKE cluster with 3 instances, right? We didn't have to even think about it. Another thing is within with GCP, we don't expose the master node. These are the worker nodes of our GKE cluster. Right? So it's that quick. And similarly for getting a AI platform Jupyter notebook, right? If you had to do it on-prem or like in a VM, you have to install all the libraries and things, but all of these things has been instantiated for you. Okay, we'll give it a minute. So Meanwhile, if you have any questions, go ahead. I'm also going to tell you, like, okay, so here do you see this, service accounts? I'll just tell you what service account is. So typically, we don't recommend having users direct access to the cloud console. You should be creating things using like a service account. Service account is more like a batch user ID or a system user ID that is used to spin up and run things. It's kind of similar to even when you're running a production work jobs in most of the enterprises, they have like a batch user ID, a system user ID that does these things, and you give it the right permissions. And you should be also adding labels. So labels is what is this instance created for? So you have some accountability and tracking of who created this. Now, some of the challenges that I see across, even my previous employee, we ran into that. Even some of the customers that I'm supporting, they don't know how much they are spending. I mean, they know the total number, but what was the underlying breakup of all the resources and things? So you should be using labels so that you are able to justify, okay, this was what the spend was for, this was for this specific experiment and things. Okay, so now we have the Jupyter Lab environment created. Let's open it. So while that is happening, to go to the section, there is an option that talks about cloning your sample code, right? So when you're there, go to this terminal and open terminal, right? So you see this terminal, it just opens like you're interacting directly with the underlying virtual machine. So once you're here, hit this git clone. So again, when we have this VM has been provisioned, there's a lot of library and frameworks that gets created underneath it. While we are here, you could also do this. Let's do cd /, go back to your home directory, cd ~sign. And I'm going to share this additional code repo that you could clone. So I'm going to also clone this, git clone. I'm going to paste this command, or if someone else could also share it. So we'll just make sure we have, because we have time, we could go through both the labs, both the Jupyter notebooks. Okay. So when you do that, it creates another folder called ML design patterns. We have pipelines and tutorials. So remember, when you copy the command, it had git clone followed by cd pipelines. So you should remember to go back to the home directory and clone it. Once you're done, let's go back to time. Once you're here, so if you go to see in your Quick Lab notes, go to samples code, like you would see AI platform. Okay, so before we go there, we have to actually run this command, right? So what we're doing is we're going to set the project ID, right? So let's copy this, export. Okay, so it's just setting my project ID. I'm going to set the region as central 1. So regions are locations where our data centers are located. We have regions, zones. So that we have within US, we have multiple regions, like for example, US West 1, West 2, and within a region, you have multiple zones. So that is where our data centers reside. Next, we're going to create a bucket, which is like a cloud storage bucket. And the command for that is gsutil make bucket. In this case, we have created the bucket with the same name as the Quick Labs project name. Okay. And next, we just created the bucket, so it should not have anything, but it's just going to list. Oh, it also has another bucket for Kubeflow pipelines. So when Kubeflow pipelines has been created, it needs a bucket to store all the artifacts that it is. When you run experiments and everything gets stored here, and the metadata is stored in the Cloud SQL. Okay.
Bibin, Veena says she saw you tick the option to use manage storage when you created the cluster, but in the documentation it's unticked. Does it affect anyway?
Oh yeah, don't click it. I thought I didn't select it, but then if I did, but don't select it. Yeah.
Okay, thank you.
Yeah. Now going back to the pipelines thing, so we would need this. So you need the settings. So once you're here, you need to copy this host information. Like this host information would be different for each of your environments. So make sure you're copying this from the starting till the end. You would need that in the Jupyter notebook. Okay. So going back to so the notebook that we're going to open is AI platform that's PYNB. It's under pipelines sample score AI platform. So pipelines samples core AI platform.notebook, right? So take it and just copy it. What was it? Oh, so remember this. I don't think this was actually mentioned in the instructions. So make sure you're commenting this, okay? And you could just have this. Okay. I don't know, Vishal, did you have any issues? I thought there was some issues when I ran into this. Okay, but anyway, just comment this first line and change the host here. Another thing is we need to also add the GCP project here. So your project, going back here, you could just copy it from here, the GCP project ID. Paste it in this. And the storage location, right? So the storage location in this case was, I think we used this. Oh, no, in our case, I don't think it matters, but we created, the bucket that we created was this, right? So we just copy this. I'll copy the project name. Okay. So once you're done with it, so we can go ahead and run this. So remember, there is also, we need to restart the kernel. So what we're going to do here is we're going to install Kubeflow pipelines, a specific version. Takes about a few seconds to install that. Okay, so once you have installed it, make sure you go to kernel, restart and clear all outputs, or just maybe even restart kernel is fine. Okay. After that, we're going to import some libraries. Importing the JSON library for JSON processing, Kubeflow pipelines, your DSL, pandas, and then some time. So once you're done with it, again, go ahead and run the next step. We've set the project ID and the output location. The next are some parameters that are specific to your region, runtime versions. Now, in this case, we are actually using, so let me go back to the example, what we're going to do, right? I don't know if they have explained it over here. Okay, no, maybe, I think it's already, okay. So in this case, we're going to download data from BigQuery, create a Kubeflow pipeline. We're going to deploy that on AI platform. We're going to submit a job for execution. Now, what does this model do? It is going to forecast how many crimes are expected to be reported the very next day. And the history that we're sending to it is the previous n number of days. Right? So that is what it's going to. Okay. These are just variables that you have defined. You're calling it Chicago pipeline model, model version, and things. So here is a big, so now think about, so in Kubeflow, you have different operators. Now you would see something that is commonly, you might not see it in other things, but these are, it's pointing to a resource on GitHub, says, okay, I want to use this specific component for BigQuery, and it is to load, to do certain functionality. Now, what I would recommend, again, from a experimentation and trying out things, it's good. But when you're deploying this into your enterprise, typically these kind of references to external GitHubs would be prohibited. So you might have to think about downloading this and putting it into an internal repository, something like Artifactory, or it could be even Google Cloud Storage or somewhere. Like you need to, and then change the link, just letting you know. So you're defining a BigQuery operator over here. Okay. What it does is just selecting the count and the days from the Chicago. This is a public public data set, and you can actually go and query this in BigQuery, and you could see. Let's do this. Remember, since we have some time, we could actually run this query. You could also look at the BigQuery UI. So go here, like click on the hamburger menu, go all the way down, and you would see where was BigQuery. Yeah, click on BigQuery. Right? Okay, hit done. Now let's copy this. So BigQuery is our public data set, and we're going to look at so public data set, and then within that you have the Chicago crime is the data set, and looking at the crime table. Okay. So if you look at the query, look, it has processed about 54 MB, and you got the results. Now look at the execution details, how much time did it wait, how much bytes and things. But just showing you the UI. But again, once you are deploying this in enterprises, you are not running a lot of things through the console, unless maybe some data analysts might be able to have access to the console, and that's how you would interact with it, but not on an application, enterprise application perspective. While you're exploring your data, this is how you would look at it. Okay. So ran this. So the next one is ML Engine, right? So ML Engine is our platform where you could deploy your models. Now think about this again. Let's say you have a home value prediction of model that you have built custom in-house, and you want to deploy it somewhere. You don't want to be worried about the infrastructure to scale up and down, right? So for that, you use ML Engine, which is available on AI platform. And again, in this case, you could see that I was again referring to one of the components on GitHub. Like I said earlier, to move it to an internal repository in an enterprise. Okay, so the next one was a training. So the way it works in, let's say you want to train your model, and with a lot of data set, you submit a job to ML Engine. You also have a deployment option where once you have trained and you have got the results in, you could save the results in a cloud storage bucket, and then you point, this is the model on the cloud storage bucket that I need to deploy on production, and this is the operator for it. And other thing is, when you can also create your own custom operators. When you're creating your custom operators, think about these, right? What are the parameters that you need to pass it into your custom operator, and what are the parameters that you need to so that's how you modularize things. So next is you're defining your pipeline. So you define the different operators, like reading from BigQuery, training, and deploying it in ML Engine. And next, you define the entire pipeline as these components together. Okay. So next, we're going to submit the pipeline for execution. So before you submit, please make sure your host is correct. You've copied the right thing, and you have commented this line out, the first line, right? Look at it, just creating the same things. The other one would have been trying to create from an existing one. Oh, sorry. Again, when you're doing this, make sure you have in Python, indents matter a lot, right? It's not like other programming languages. So, and then run it, right? So now what has happened is we have submitted a job that's going to run in Kubeflow pipelines. So while that is going on, we can go quickly take a look. So there are two ways to go. You can either click on the run link or experiment link here. So it's going to take us to the Kubeflow console. So we have submitted our experiment. So this is the, it's just going to start up. So it will take some time, maybe like 5 minutes. So meanwhile, we're going to also start our other piece of the Jupyter notebook that we have cloned, and we'll go through that. So this will take a few minutes. If you are all, so let me know if everyone is here. Should I wait or should we go to the next Jupyter notebook? You can just quickly say post somewhere.
Yeah, we'll wait for 2 to 3 minutes maybe.
Okay, cool. We'll wait there. So while that's happening, I'll also say, okay, once the job gets submitted, you could actually come back to AI platform jobs once it reaches that stage, and then we would see it. But right now, it hasn't reached that stage. Actually, it's still, oh, it's actually submitted now. Good, right? So it has finished the BigQuery part, and now it is doing the training piece of it, right? So it says, oh, so my time is like 10:43. It just got submitted like a few seconds ago. This is the start time. You can look at the view logs. So again, so to answer the question earlier, right? What is observability? Like logging and looking at the logs, these are all part of your observability. How is your model performing? How it's all of getting all that information. It's still starting, so it might take some time to finish. But think about this, right? So you're not provisioning any resources and things. In this specific use case, they're deploying the models and doing all the training in AI platform. Now you could also deploy your models within Kubeflow. Kubeflow also has a model serving. It's called as Selden. You can do your serving there. But people might choose, okay, I don't want to do all my serving, and for production use case, I might just use my Kubeflow environment for just building and doing my dev work, and then deploy it in AI platform. The option is there too, right? So let's go back and check in Kubeflow pipelines. Look, our BigQuery piece has completed. Now let's take a look at what are the things you could see there, right? So what were my input and outputs? So we had a GCS path location. This was the project ID. And these things are critical, right? So where is my output stored? So it shows it is being stored here. And you can always have somewhere to go and check all this information, right? So if you want to come back and compare my different runs and what are the results, you could all go through this. So you can look at logs, what happened there. Now think about this. What it has done is it has taken the code that we have created and created a container out of it. Okay. So we are saying this is a pod. So pod is more like a runtime instance of your container. You're instantiating a container as a pod. And it has done all that seamlessly behind the scenes, so we don't have to be aware of. So you don't need to know how to define a YAML for Kubernetes. So that is the beauty of it. Like people, oh, like it's like more complicated, and getting all the right tabs and syntax. You don't have to worry anything about that. It has been taken care for you. Okay. So this is running. Okay.
Bibin, since you brought up the discussion about YAML, there's a question that's very similar to the one that you may answer in this context. So
Okay.
it's from Veena. She says, how to set the pipeline in Kubernetes? I'm a novice in this subject. Should I have the code be written in the YAML file? And thank you for answering.
No, so you don't have to write it. So that's the beauty of this, right? So you create your own operators, and Kubeflow takes care of converting it into a container and creating the YAML files and submitting it. In some cases where there are even operators where you can convert a whole Jupyter notebook into a container. There's a function for it, or there is a binary for it. So you don't have to worry about it. Okay. So in the interest of time, it might take a few more minutes for the training to complete. So I think we could go ahead and start the other lab. Not the other lab, we're not going to start in there, we're just going to open the other notebook, right? So ML design, go to ML design, number 3, problem representation, and then we are going to open cascade.python notebook. Right. So in this case, it's going to, again, use BigQuery. What we're going to do is we're going to create a model. And you can see an example of how to create a model within BigQuery. In this case, I think earlier there was a question around like what are the different kind of models to create, what is this approach. So here we're going to create 2 models. One is going to create a linear regression and the classification. So in classification, we're going to classify whether a bicycle trip is going to be a long trip or a short trip. And then in the regression, we're going to predict a number, how long is the bike going to be ridden. Otherwise, the person who is renting the bike, how long is he going to ride the bike? Okay. So let's go back to the AI platform notebook, copy the same project ID that you have. So you have your project ID here. Replace it. And then same thing for Kubeflow, the host. Go back to this section and just copy this. Okay. So next is, so again, this specific command, this is a DQ binary, right? So whenever you're running jobs, like, yeah, you have options to create it through the console. But here is like typically when you're submitting jobs, you can do a BQ file load. In this case, you're going to show the ML patterns, which is looking for a data set. If a data set is not there, it'll create the data set. So when you hit this, said, oh, we don't have a data set of this name, is going to create that data set. So if we go back to BigQuery and go and just hit a refresh on this screen, should have created your data set, right? So this was the other data set that is getting created as part of the other job that we are running, but this is the ML patterns data set that just got created. Okay. So next, going to import Kubeflow. In this case, again, remember like the one earlier, we are just going to load the BigQuery load operator. Okay. In this case, it also tells when you see, okay, help, what does this operator do? It will give you what does the operator do. The Kubeflow pipeline to component to submit a query to Google Cloud BigQuery. So that's a good option. If you want to find out what an operator does, copy this, and in our case, what are the operators we did? Like we had an ML engine and deploy operator. So let's try that, right? Let's see if I put this and just copy this. No, it tells you what that operator does. Okay, so this is Kubeflow component to deploy a trained model from a cloud storage part to a cloud machine learning engine service. Okay. So once you're done with it, next, we're going to import it. Importing is similar to the other one, like importing a JSON library and the OS library. And in this case, we're going to run a few, create a few models. In this case, classifying a trip. So that is your classification problem, right? A logistic regression. In this case, you can say, okay, is it going to be a short trip or a long trip? The second one, we're going to create Bike share trips. This is going to just create the training data. In this case, it's going to create a model where it's going to predict the distance that the bicycle renter is going to ride the bike. It's a linear regression model, right? So you can see the linear regression model specified here. In this case, those are logistic regression. So we're going to run this, right? So for each models, you're providing some data set to train, right? So that's what's happening. So completed that. And next, what you're going to do is extract the pipeline, and then we'll upload it to Kubeflow. Okay. So we have done that. Now let's go here and check. Go click on this or go back to the old link and look at experiments, right? So now we see another experiment that has also started called the Cascade Pipeline. So click on the Cascade Pipeline if you are there with me, and then you could see, okay, what's happening here. Let's take a look at the logs. It's still starting. It might take a few minutes. While this is going on, you could go back and check your previous experimentation and what's happening there. So think about this in one environment now. Oh, look, in this case, the training job has completed. Right? So look at the logs. The training jobs have succeeded. If you want to also go to AI platform and view it, let's look at it. See, the training job has completed. Let's see what is the result, what all things that we could see from the training job. So it shows you the memory utilization, the CPU utilization, training input, training output locations. Okay. You could also download the model from here, but it also gets saved. Now coming back here, take a look at the models. Okay, so it's getting deployed over here. So we did the training and now it's getting deployed. So it's still happening, it's still going on. So it might take a minute or two to have complete. While this is, any questions? Like, I'm jumping back and forth between both the experimentation so that I can show you how things are, get some more examples. Still taking some time to run. Can ignore this error. There's a protobuf version thing. That's just a so you can ignore this. You could see that it's capturing the logs, what's happening. And if you want, you can actually go back here and click on refresh, and you could see the models getting created in BigQuery too. See, I'm started. My model is here. Tells you it's a logistic regression. Once this comes, oh, you can see, okay, this is the loss, this is the duration it ran, this is the learning rate. You can see the evaluation. So this is the beauty of it, right? So think about this, even within BigQuery where you have your data, your data lake, you do your model training and deploy it. Right? What else? Okay, good. So you can see in this case, our second pipeline, it has created both the DDLs, is going to the next DDL of creating the distance and predicting the distance, right? So it's happening. Okay. Let's look at the previous experimentation if that got completed. The experimentation has completed, right? Let's see. Submitting a cloud job has succeeded, and deploying the ML model. So that has also succeeded. So it's the TensorFlow job that got submitted on this. So the framework was just TensorFlow, that's it. But it's not like it's a BigQuery prediction. Sorry, it's a TensorFlow prediction. I got it. Coming back, so let's take a look. Take a look at this. The Chicago pipeline model. Now, the interesting thing is, if you want to see, you can actually test it over here. If you provide a sample test data, it will actually give you a result. So we could complete that. Let's see, was there other steps here? Yeah. Okay. So in our case, going back to the AI platform notebook, since all the training has completed, let's see this. Run the next step. So it says, okay, the model has completed, your training job is completed. Look, so it has, you could actually hit the endpoint and it will give you a prediction result. Now that's pretty much it. Like, how do you hit an endpoint? Now, in our second case, still running, that is also has completed. Okay, so let's take a look at the evaluation score. Logs. Was there any outputs? Okay, all of those got logged, right? Now, going back to BigQuery, you could see all that. You can verify that. ML patterns, you could see. So classifying your trips was a logistic regression. Predicting the distance is a linear regression. We also have one more, another predicting a distance long or a typical distance. And these were the training data. And you can look at the evaluation of this, your training evaluation. Okay, cool. So I think with this, we have completed the lab. We have completed 2 labs in the same the duration. Do you have any questions?
Meanwhile, do you want to go over the Q&A that users posted, or only questions related to this particular?
No, we can go through. Yeah, we can go to the Q&A.
Okay. Yeah, Kaushik, can you continue with the question?
Sure. All right, there's a question from Gideon. He says, what is a clear or simplified difference between data proc, data flow, data lab, and data prep?
Okay, so can you just post it over here so that I can read it? So you said one is data proc, right? So data proc is our managed Hadoop environment. So it's an interesting, really good question. Like we had like about, when was it? I forgot it. At least 10 to 15 years ago, maybe I forgot the exact date. We had written the paper for that was used by Yahoo to create the whole Hadoop ecosystem, right? That's how it started. But within Google, we have actually moved on. We don't use any Hadoop infrastructure for all our internal processing, but we do support Hadoop for our customers who are using Hadoop on Dataproc. But what we typically recommend is try to move away from the Hadoop infrastructure and move to something more serverless, like you can run your workloads in BigQuery instead of Spark. You could use Dataproc, which is a managed Apache Beam. So that answers your second question. So what is data flow? So data flow is for, you can compare that to Spark, where you're doing all your processing on real-time streaming or even for batch processing. And we support different languages, like we support Python and Java in data flow. And also we have introduced SQL for data flow. I think somewhere here, I forgot where was it. We did have, I forgot. So within the BigQuery editor, you had an option to even query the Spark streams. Sorry, the data flow streams. So the third question I remember was, sorry, the third thing that you asked was data lab. So data lab is kind of deprecated. It was as an option for Jupyter Notebook, but now what we have done is we have embraced managed Jupyter Notebook. So I would say don't even, so that, I think data lab was in the path of sunset, I think early last year. So just think about using managed Jupyter Notebooks within AI platform. What is the fourth one that you had asked?
It was data prep. I posted the question in the chat so that you could actually see.
So data prep. Okay, so data prep is more for, I would say, like data analysts. If you want to use data flow and you want to do some data preparation, data parsing, pre-processing your data before you write it into BigQuery, you can do that. Some of the callouts that I have, it's all GUI based. You drag and drop and create your workflows. It's a third-party product that is integrated and provided within GCP. But it's really good for people who don't have an engineering background. So it's really intuitive. You could say, this is my source input file. I'm going to do these kind of transformations on top of it, and then I'm going to write it into a data store. And behind the scenes, what happens is it generates data flow jobs, and then it spins up all this transformation and handles it for you. Does that answer your question, Gideon?
There is a quick lab which has data prep in it, so you can try it. Yep. The only thing I ran into is I think it's required at that time. It required Chrome. So if you use Firefox, I would rather use Chrome. But otherwise, it's pretty nice, even if you are an engineer.
Okay, so question, Guhan, to answer what is TensorFlow like? So TensorFlow is our AI like framework, which has been open sourced, just like another platform like PyTorch and things. It's a Google product. So I think, like, from our perspective, we support all the frameworks within our AI platform. Let's say there might be some frameworks that we don't support, but the way I would recommend is, if you want to support like other frameworks that are not supported directly within AI platform, run it using containers. Like, the beauty of containers is, again, the libraries and things that you require, it can be installed. You can just specify, this is what I need in my container, and it'll automatically download it. But at a high level, TensorFlow is just an AI framework to build your models on. And you can import those libraries into Python and then build it.
Okay, can you go over the other questions?
Yeah. So I posted another question from Raja. As a sysadmin in a company that is just starting with ML or AI, what kind of criteria should I be considering in sizing and provision with GCE plus GPUs for ML training?
Okay. So interestingly, like, one of my customers, they use a lot of GCE and things. There would be some limitations. Maybe let's say, like, why they chose that to run it on GCE, right? Let's say, like, I know, like, H2O is a commonly used framework. So one of my customers, they run that on Compute Engine. But if you're just starting the journey, right? Like I said earlier, look at this slide, right? What was the slide? Think about the slide that I showed first. Make a choice here, right? Let's say, can you elaborate maybe a little bit on, like, are they trying to solve a structured data problem or an unstructured data problem? Let's say if it's structured data, something like forecasting or a propensity to buy, you could do that using BigQuery. You don't even need to go to, like, in a Compute Engine, right? And this is what I would want. Like, one of my other customers, they had a simple requirement for propensity to buy. They had a third-party partner who was building a simple linear classification or a logistic regression model, and they were using a big Compute Engine with 96 cores. The moment I saw that, look, let's say, well, then you could go with something on BigQuery, or you could even use AutoML tables. Even within AI ML, our AI platform, we have, what was that? You could submit jobs where you could, you could create, let me show you one example, right? I could create a new training job and I could use built-in algorithm training, right? Can select one of these algorithms that are out there: XGBoost, linear regression, wide and deep, image classic image detection. Also, there is AutoML within BigQuery or AutoML. So, unless there is a genuine reason why you're using compute engine and starting with that, I would recommend try these options first. Go through this decision process, and to have more detailed things you want to ask me, feel free to ping me on LinkedIn or after this, and I can walk you through
that. This is another question from Joe. Within the ML maturity lab, what kind of tools would you suggest to implement auto monitoring and auto rollback from failed canary testing?
So tools, automated. So one thing I would say is, okay, all of these are getting logged. Now we have to build additional processes on top of it. Let's say one simple example is accuracy score, right? Let's say if you're seeing the accuracy score is going down, and if it is below a certain threshold, you have to have like some kind of metrics that is being captured, and that will trigger a cloud function, right? And then that can trigger a function and do some action based out of that. You should not be relying on someone to come and tell you that, oh, the model score has gone down, he'll go take an action. This is what I would recommend. If there is a model drift that is happening and you're capturing everything in the logs, come up with a parsing function that captures those logs and does a comparison. Like I'll give you an example of, again, this was from my retail days. We used to define alerts. When I'm generating a forecast, I automatically wanted to stop certain SKUs that are being forecasted from going and creating a purchase order. The way we defined that was, we defined, let's say, in case of forecasting, compare my last 4 weeks of forecast with my 4 weeks of, last 4 weeks of history to my 4 weeks of forecast. If there is a deviation or a threshold difference, I want it to be stopped, because let's say the last 4 weeks of selling pattern was only 2 units per week, right? And suddenly I'm forecasting like 20 units per week. It could be an accidental fat finger typing. Like this has happened really. Like when I was supporting someone had accidentally, instead of when they were trying to override a forecast, they accidentally pressed the number, it got stuck. It created a very big number. And the alerts caught it and it failed. So those are things that you have to define. There's multiple approaches to it. So this was just one example, like defining alerts, defining thresholds, and continuously monitoring these thresholds that are being generated.
Okay, we have another question from Sukhasis. If the input data layout has changed, do I need to retrain the model, and how do I do that effectively?
So when you say input data layer, if you're talking about like in the streaming or if it is in the file layout, I would say by you're doing some pre-processing on top of it, right? So you're coming up with these formats. Let's say the input file format has changed. Let's give you an example. If assuming that, let's say it's JSON format, right? If it's JSON format, I'm not going by just the input file format. I know which are the fields that I want to parse out. You should actually be putting some checks. Like, for example, again, this is not cloud native specific, but like when I was loading a lot of sales files, or product information, we used to get special characters in it, and that would usually cause our systems to fail because sometimes some characters are not accepted in some of the databases. So we used to have all these checks, and then in order to prevent these records from going into it, we would catch it. But if you're talking about the entire file format changing, it's not as flexible as JSON. Once the data model changes, you might have to do anything at least to handle your pre-processing. I don't think it impacts a lot unless you're saying some features are going to be completely missed, or let's say you identified some new features that are going to come in, right? That might improve your model. Let's say initially when you build your model, you thought about maybe 10 key features, but maybe your business analyst feels that these additional inputs might improve the accuracy, then you have to do that feature engineering and feed it into the model. That's what I would say.
All right. There's a question for an earlier question from Saba. If Data Lab is getting sunset, what is the successor service?
So that's what I was showing earlier here. AI platform. Within that, we have Jupyter Notebook. So use everything. So this is our successor, like open source Jupyter Notebook in our platform, and we have few options for this. The easiest I would recommend is go with AI platform Jupyter Notebook. You could also create a Jupyter Hub on Dataproc. So when you create a Dataproc Jupyter Hub instance, behind the scenes it creates a Dataproc, which is our Hadoop, and deploys it there. But I think to make it more easier, it might be AI platform might be a better experience. Jupyter, like our Jupyter Hub is relatively new. It got released in the last 3 to 4 months.
All right. So we have another question from Manuel Fernandez. Can we know a quick case study of what TensorFlow ML is used and what conclusion it would predict?
So that's a bit generic, but let's say, for example, like any of the problems that we spoke today, right? You could build that in TensorFlow, right? In the past, I have experimented creating forecast using TensorFlow, but I've also used other libraries. In most cases, we should be that this framework, just like any other framework out there, PyTorch, you could use it to build any models. I don't think there's one case that fits all, but when you're picking your options, I would say always look at this flowchart, right? Why do you want to build, like these are all of the other libraries. You could do it in R, you could do it in Spark ML, you could do it in Keras. I mean, Keras is like, it has an abstraction on top of it. Scikit-learn, these are all just frameworks, but prior to going and starting to build your own code, think about all these options that are out there and then decide whether you want to go with TensorFlow and build your own custom model.
Yeah, another question from Alok. Is there an RL pipeline example like the YouTube recommender PPO?
What pipeline? Sorry, can you repeat that?
Pipeline example like the YouTube recommender.
Like a YouTube recommender. Okay, so it's interesting. There's a lot of customers that has a similar requirement, right? So one is YouTube recommendation. Netflix has come up with their recommendation, but that any kind of metric. So metrics factorization is one that we also have in BigQuery. So you could think about like, what is metrics factorization? Let's say from a YouTube model, like these are all the videos. These are all the people or groups or cluster of people who are interested. When you talk about cluster of people, it could be age or whatever, like all the other factors that goes into it. And so that one would be in your x-axis and your y-axis, and then the combination. So metric factorization is supported in BigQuery. You could try it out, and it should be good.
Yeah, there's another question from Kuhan. Jupyter Notebook uses port 8080 with internet browsers, right? How does it work with Linux operating system and containers?
Oh, I don't have the answer, but if you have to install on top of a Linux environment, it should be working. Or other things, I think you should be able to change your port. Like these are all the default ports that are specified there, right? And assuming that the ports are not being used on the Linux server, you can always override the ports. That would be my answer.
Yeah, I do not know if the link answers the question, but I've just posted a link to the working of Jupyter architecture for that notebook. How does it work in different environments? So,
I am with Linux, by the way. I'm using Linux, and it's, I mean, if you are using the Jupyter Notebook with GCP, then it doesn't matter, right, what OS you have, because it's running up in the cloud. Otherwise, like if you install anything like Anaconda, works well on Linux.
all right, I think that is all the questions that we have at the moment.
And I'll be sharing the slides after this. I'll just make it as a PDF, and then I will put it on the ML attendees Slack.
Yeah, Bibin, do you have anything to show with the lab still? Or?
No, I think the labs were done, right? So we had completed all the things, like both the pipelines had completed execution. There's nothing much, like, just showing you how to run this whole labs, how things are automated, like from an data scientist or an ML engineer, you just have to run it from a Python notebooks, things are taken care and deployed on AI platform, right? So in our case, we saw how the models are also deployed here. Once a model is deployed at this, you have an endpoint prediction that automatically scales up and down. So that was
Okay. Thank you, Bibin, for answering the questions. As Bibin said, you can connect with Bibin on LinkedIn. We will share his LinkedIn profile over the PPT that we will share after the event. You can connect with him and ask any other questions if you have any specific questions. Okay, now let's go to the exciting moment, feedback and raffles.